So for this second question, it's asking which statements are true, and it gives 5 different statements. So let's go through each statement one at a time, and let's see if we can prove which ones are true and which ones are false. So the first statement says that if the limit of a sub n is equal to 0 as n approaches infinity, then a sub n series should be divergent. So if the limit as n approaches infinity of a sub n is equal to 0, summation of a sub n is divergent. Well, according to the test for divergence, the test for divergence says that if I take the limit of a sub n and it is not equal to 0, then a sub n is divergent. If it equals 0, test for divergence tells us nothing, and we have to try another test. So this statement is false. If it was not equal to 0, then this statement would be true. The next statement says that if I have a series of n equals 1 to infinity of 1 over n to the natural log of 7, is that series convergent or divergent? Well, from what I see, we have a p-series test. We have 1 over n to a power. ln of 7 is just a constant. So the question is ln of 7 greater than 1? It is. ln of 7 is a little higher than 1 in this case, so it should definitely be convergent by p-series. So this statement is true. Question 3. Question 3 says that suppose if a sub n is less than b sub n and b sub n diverges, then a sub n also diverges. Well, that sounds like a limit comparison test. So if 0 is less than a sub n is less than b sub n, and b sub n is divergent, then so does a sub n. So if this diverges, does this diverge as well? The answer is no. And the answer is no because remember, if this one diverges, it says nothing about this one. This one has to diverge for this one to diverge. So it has to work the other way around. So if a sub n was divergent, then b sub n would be divergent. But this way around doesn't tell you anything. If you got a direct comparison test that yielded these results, you would probably have to try either limit comparison or some other test to prove convergence or divergence. Question 4 says that if I have two summations, a sub n and b sub n, that are both divergent, is summation of a sub n minus b sub n convergent? Well, according to this, if I have two series that are divergent, subtracting them doesn't change its behavior. Now, if a sub n and b sub n were convergent, then the subtraction of a sub n and b sub n would also be convergent. However, if these two are divergent, just subtracting them does not change the overall end behavior. So this statement is not true. So 4 is not true, and 3 is also not true. So the only one we've proved so far that's true is number 2. So let's move on to the last statement. The last statement says that if I have the summation of n equals 1 to infinity of negative 1 to the n over n to the 5th root, so n to the 1 over 5, and I also have the summation of n equals 1 to infinity of negative 1 to the n over natural log of n. Are those two series convergent? Well, let's see. So in this case, I do have n to the 1 over 5, but I have an alternating series on top. So all I have to do is prove whether or not this holds with alternating series. Again, the question doesn't say anything about conditional convergence or absolute convergence. I'm just looking for convergence. So if it converges by alternating series test, it converges for this question. So for alternating series test to hold, my b sub n, the limit of b sub n as n goes to infinity has to be 0, and b sub n has to also be decreasing over time. So my b sub n in this case is 1 over n to the 1 over 5. So if I take the limit of that as n goes to infinity, is it 0? It is. So 1 over n to the 5, the bottom is growing, the top is not, so therefore it should go to 0. So it satisfies that first criteria. The second one is that b sub n plus 1 has to be less than or equal to b sub n. So the way that you can prove this if you're not sure, take the derivative. So if I take the derivative of 1 over n to the 1 over 5, I end up getting negative 1 over 5 n to the negative 6 over 5. So I have a negative sign out front. Because that derivative is negative, that means that the will be decreasing over time. That b sub n will be decreasing over time. So, knowing that, I know this first one is okay. Second one is negative 1 to the n over n ln of n. Same criteria, it's an alternating series. Let's prove it using alternating series test. So my b sub n is equal to 1 over natural log of n. The limit of that as n goes to infinity is indeed 0, so limit is equal to 0, satisfies that criteria. And is b sub n plus 1 less than or equal to b sub n? It is. The derivative of natural log of 1 over natural log of n is natural log of n negative to the negative 2 times 1 over n. There's a negative out front, so yes, it should be decreasing. Satisfies both those criteria in that case, so this one is also convergent. So therefore, I end up getting that statements number 2 and statements number 5 are both correct, which means that my answer has to be E.
The Teaching Center, UF's Learning Resource Center.